I'll be only using for uh, share if you want, right? Okay. So the pressure is around 0.05 mercury millimeter and voltage is around 10,000 volt. Very high pressure and very high voltage and low pressure. Sorry, very high voltage and low pressure. This is continuously asking in your term test. Remember, they use very low pressure and very high voltage. During this time, when the voltage is around 10,000 volt and pressure is around zero point 0.0 mercury millimeters, they saw very wonderful thing. Very wonderful thing. Right? So you can see inside the tube, it is almost a vacuum, but almost a vacuum. It is not necessarily a vacuum. This can be done with the vacuum as well, but within very low air pressure. They saw a kind of a glowing around the cathode, a glowing here, a kind of a glowing. They could see it. And when they continuously continue to do the experiment, remember this observation, right? First, they saw a kind of a glowing around the cathode. And they saw something move towards the anode, started to move towards the anode. They saw it. They were very surprised to see it. Very surprised to see it, right? So when the pressure further reduced, that means it is uh, initially the cathode is glowing. Cathode was glowing like this, right? It's glowing. Then something started to flow from cathode to anode side, from cathode to anode side, like this, and they further reduced. Then what they saw was some rays are moving towards this direction. Some rays are moving from cathode to anode, from cathode to anode. There were no color for this. How they identify was, remember, there was no color for these rays. How they identify these was when they hit on the glass wall in anode side, it glow in green color. Not green color, exactly green color, but some glow has been emitted. There was some kind of glow in the glass wall. That is because of these rays, right? From which direction to which direction these rays are moving? From cathode to anode, cathode to anode, cathode to anode. This direction, cathode to anode, cathode to anode. It is moving. There were no color for these rays. Remember, there were no color for these rays. There were no color for these rays. I am repeating this question. This is there were no color for these rays, but when it hit by the anode side glass walls, not on the anode, in the glass wall, it emitted some color. Let we can say that is green or yellow or something like that. Right? Let's say that some color is emitted, was emitted. So they knew that something is moving from coming out of from the cathode. What are the conditions that during this time? What are the conditions? High voltage and low pressure. High voltage and low pressure. So they gave a name for these rays as cathode rays. Cathode rays because they were emitting out of cathode. But they didn't know what this is. because their intention was to send the electricity through the air. At least they didn't know that this is electricity. But finally they found out that this is something that completing this circuit. This is a high volt, there is a high voltage, and there is an anode, and there is a cathode, and it is completing the circuit, and they assume that this is happening because of uh, because of completion of the circuit, and these rays are completing the circuit. It is not. There's a very good question. So the glow was seen only behind the anode or through the entire tube. It is not through the entire tube. It is behind the anode. I will explain it. Right? Not the entire tube. But this glow has been seen uh, across the entire tube because it was very dark. When there is low pressure, it was very dark. So they knew they saw it as the glow is coming out from the total tube, but it was not like that. If you light a torch, if you give some kind of light in dark, you may see it is all over the light is all over the place, but light is coming only from the light or the torch. The same thing happened here. The glow was only from the anode, not from the anode, behind the anode. So because these rays are going to hit by the anode and the wall behind the anode, and there is some kind of glow. Because of that glow, total tube has been blossomed or lit. Are you following me? Yeah. Okay. So when you apply kind of a zinc sulfide, remember, when you apply some zinc sulfide in this glass tube, zinc sulfide, when you apply zinc sulfide, this was not done by crooks, huh? Remember, this was not done by crooks. This zinc sulfide thing, this is something happened at a later stage. When you apply zinc sulfide on the glass wall, it gave out green color when it is hit by these rays, these cathode rays. What is the color? Green. That because of some reason that we will be learning that one in inorganic chemistry. So this is the invention of cathode rays. Who invented the cathode rays? Who invented the cathode rays? William Crookes. So William Crookes, he gave the name cathode rays. He gave the name cathode rays because it is emitting from the cathode, not emitting from the anode, not from emitting from any other place. It is emitting from the cathode surface itself, from the cathode surface itself, not just uh, 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 be, across the cathode or away from the cathode. It is emitting from the surface of the cathode. Remember that. Huh? This is asking. This will be asked. It is emitting from the surface of the cathode, and because of that, it is called as cathode rays. And it is going towards the anode. It is going towards the anode. But unfortunately, William Crookes didn't know what these are rays made of, what these rays are made of. He didn't know. Because he carried out these experiments at the latter part of his life. And Hitolf and Fluker were not capable of doing or continuing the experiment further. Right? So this is the Crookes experiment, and this tube is called as cathode ray tube. Sometimes this is called as Crookes tube. Now this is called as electron tube as well. It is not commonly used, but Crookes tube or cathode ray tube, those are the two common words that we are using. Right? What is the shape of this tube? Sausage type. thin and long, right? Not that much fat, right? Very thin and long one. And he placed, I'm explaining again, and he placed two metals in two sides of the cathode ray tube, the Crookes tube, and he put high voltage and he continuously decreasing the pressure. It is almost a vacuum, but the pressure is around 0.05 mercury millimeter mmHg, right? So when you decrease in the pressure, he observed some kind of certain glowing around the cathode, and when he further reduced the pressure, he saw something is moving from the cathode towards the anode direction. When it is hit by the glass wall behind the anode, there's some kind of glowing was there, and he came to a conclusion that there are some rays moving from cathode to anode. So he called these rays as cathode rays because they are emitting from the surface of the cathode. So this is the idea, or this is the experiment. This is called as Crookes tube experiment or cathode ray tube experiment. If you have been asked to explain this, you should be able to do this. Okay, guys, are we clear? Any questions before writing down the note? And when there is a zinc sulfide coating applied uh, in the cathode ray tube in anode uh, direction, anode side, it glowing green. Was there a color for this cathode rays? Does cathode rays has a color? No. Cathode rays don't have a color. Yes. But when it is hit by the glass wall, there is a color. We don't need to remember, we don't need to know the color. But when there is zinc sulfide coating, it glowing green. That need to be remembered. So sometimes they ask, yeah, what does the suction pump do? Suction pump do is it is reducing the pressure. It is sucking up the air from the Crookes tube. It is it is the equipment which control the pressure, air pressure. Okay, this sir. Yes. So it is remove air to reduce pressure. So sir, is it okay? Clear?
Yes, sir.
Okay. So this is the reason to have the suction pump. High voltage, that is that they want to send the electricity through air. I don't know up to now. There was nobody was able to send the electricity through air, right? So there are some NFC something like that uh, in latest Samsung phones, Samsung and iPhones, but it is still needs some touching for the charging. Up to now, electricity cannot be sent through uh, the air. Can I don't know. Uh, According to my knowledge, there were no. Right? Okay. All right. Are we good? Clear? Satsara? Are you clear? Yes? Okay. All right. So um, let's write down note under the topic of cathode rays. Don't write that. We wrote that the experiments were carried out by William Crookes and Hitolf and Fluker. We wrote it, right? Send it to? We wrote it, right? Okay. Now, can you draw this? Um, Draw this first, then let's explain. There's a question, is this cathode rays shows the movement of electrons as it move from negative to positive? I will come to that point. I will explain. Okay, if you have drawn, let's write down. Crooks, first bullet point, Crooks and the team. Crooks and the team wanted, wanted to send the electricity, to send the electricity through air, through air, through air. Next bullet point. A high voltage was applied. Uh, a high voltage was applied across the electrodes, across the electrode, while while reducing the pressure, while reducing the pressure inside the tube, while reducing the pressure inside the tube by using a suction pump, by using a suction pump. Next bullet point. At very high voltage and at very high voltage and at very high voltage and very low pressure, very low pressure, a certain glowing around, a certain glowing around, a certain glowing around cathode was observed. Next bullet point. When the pressure was further reduced, when the pressure was further reduced, a stream of invisible radiation, a stream of invisible radiation invisible radiation was produced from the surface of the cathode, from the surface of the cathode and moved towards the anode, and moved towards the anode, towards the anode. Next bullet point. When these rays are hit by when these rays are hit by glass wall, glass wall, it started to glow in different colors. It started to glow in different colors. Next bullet point. The radiation emitted from the cathode, the radiation emitted from the cathode emitted from the cathode was given the name was given the name was given the name within inverted commas cathode rays. Underline the term cathode rays. Next bullet point. These rays gave a green colored glowing. These rays gave a green colored glowing. These rays gave a green colored glowing when it reached the wall of the tube. When it reached the walls of the tube, which were coated with which were coated with zinc sulfide, ZNS, zinc sulfide. Zinc sulfide. Now listen. Actually, this is the invention of cathode rays. This is the invention of cathode rays. Okay. So after the invention of cathode rays, now we know that now people knew how to produce cathode rays and what. Uh, they wanted to find out what are these radiation, what is this radiation. They wanted to find out. Right. Uh, can somebody tell me what is the air pressure at sea level in mercury millimeters? What is the air pressure at sea level in mercury millimeters? Uh, I'm asking through in mercury millimeters. Annually, can you tell me, Buddha? Leresha, correct. Uh, no, wrong annually. It's wrong. Satsar, Adisha, correct. No. Satsar, can you tell me the answer? Senitu. Okay, no worries. So the answer is 760 MST. You need to remember this. Right? So this is the air pressure at sea level. And we were talking about 0.05 mmHg. And we mentioned that when it is further reduced, the glowing was there. That means it is around 0.001 mmHg. So you can understand how much of air was there inside the tube. It is very closer to a vacuum, but it is not vacuum actually. Almost a vacuum. Right? You may ask sometimes whether the Crookes tube used a vacuum or not. It's not vacuum. It's almost a vacuum. Right? Uh, it can't be seen in vacuums actually, but not in high pressure as well. In low pressures. So uh, Now we know the air pressure as well. These things you need to remember because we will be using them uh, in upcoming lessons. Okay. So uh, after finding the cathode rays, one more thing. There are some information that I am giving you in addition to the syllabus, not syllabus. In addition to the subject matters that we were discussing, that we are discussing in the class, right? Sometimes they may need in upcoming lessons. Sometimes they may need in your for your general knowledge. Sometimes they may need for physics. So just or to the mathematics. So just uh, keep your focus on those things as well. Sometimes I'm not giving the notes on those kind of things. If you need, you can make your own notes, right? You can use a pencil or something. Just write down whatever you need when I'm telling something in addition to the subject matters. Right? Okay. So now listen very carefully. Uh, People knew that there are some radiation called cathode rays, but they never knew what these are, what is the how they made of, what is the building block of this cathode rays, why it is emitting from the cathode, what is the reason for it. They never knew it. Right? They wanted to find it, and they wanted to play play with this rays because they knew how to produce them now. And most important thing is this is some kind of accident innovation, accident discovery, not innovation. Most of the accident discoveries are very important for uh, the human race. Very important. I'll be telling you those things in one point about the accident discoveries. Most of the discoveries were very important. Accident discoveries were important to human race. Uh, so this is also kind of an accident discovery, and they wanted to play with this race. Right? So people knew that these rays show some deviation in front of electric fields and magnetic fields. When we apply electric fields, when we apply magnetic field, there are some deviations in front of these fields. That's what they observe. So people, if the explanation that I'm giving, you need to listen very carefully, right? If somebody is showing a deflection in magnetic field, it should have some particle nature. Listen very carefully. Udarahano, if there is a deviation, if somebody shows a deviation in a magnetic field, it should have some particle nature. That is the first thing. And if somebody is showing some deviation in an electric field, it should have some wave properties. Wave properties. Deflection in magnetic field, particle property. Deflection in electric field, uh, wave property. So people were trying to understand what this is. Is it a particle or is it a wave? Wave in the sense that like light or sound waves, right? Like heat, right? Those are waves. Particle in the sense that you know, right? Um, it has some kind of mass. It has some kind of volume. So some people were trying to say that these cathode rays are made of some particles, some sort of particles. Some people were trying to tell that these were made of some what do you call waves. So world has divided into two parts or two groups. Some says these cathode rays are made of waves. Some says these cathode rays are made of particles. So during this time, there was a person called J.J. Thomson. We, this fellow is more like who is that fellow? Uh, Thomas Alva Edison. Very cunning fellow. And Newton. Newton is also a very cunning fellow. There was a person called J.J. Thomson. ඔය ඉන්නේ සමහර පොරවල් හැම එකම ඕන එකකුත් නෑ පයකුත් නෑ ඔක්කොම බලන ඒවා ඉන්නේ හැම එකටම ඇඟිලි එක ගහලා යන්නේ a gossip person, but he has some skill. He knows a person who knows the things. අර කියන්නේ I can do anything. I have contacts. Yeah, right. He is a person like that. Newton is also something like that. Thomas Alva Edison is also something like that. Have you heard about something called somebody called Tesla? Have you ever heard about Tesla? Not Elon Musk's Tesla. Have you heard about Tesla? Tesla is the actual person who found out AC current, electric bulb. But they were uh, taken by Thomas Alva Edison, right? So likewise, there were real Vedakara, real scientists were there in the history, but the name is shown. Oh, the shining name is the person who can advertise the things, or is the person who had more money. Same as now, right? If you work for a kind of an invention, yes, he is the Edison's co-worker. They are really nice. Tesla was the Edison's co-worker. Actually, not co-worker. He is a kind of a what do you call? He is working under him. Right? He is working under him. He's a very brilliant guy. I can't remember right now. There were many inventions that he made. Right? AC current is one of the world defining moment, but still he is not given due respect for that. He is not given. He has not been given, and he is not given right now as well. There's a very important, very interesting documentary in Net Geo. I think it was in YouTube. It is in YouTube as well. I'm not too sure about Tesla. So he has made, I think, over 1,000. No, sorry, 100 inventions, 100 discoveries, who shaped the way of human race. Right? Read them when you have time. Those are very important aspects. Right? You guys also should be real Vedakar. Right? Not a person who knows the things. No, not a person who knows a person who knows the things. Right? Alva Edison is like something like that. He is also a brilliant guy, but Newton is also a brilliant guy. When you will understand when you are learning about physics, when you learn about maths, when you learn about chemistry, Newton is all over the place. But one person cannot discover that amount of theories within one lifetime. What he did was he bought them, right? He bought them. Is it Tesla is very popular? Is it? I didn't know because during our days Tesla was not that much popular, right? How do you know, Stanley? Tesla is popular. You are not talking about that Tesla car, right? Tesla cab or something like that, right? Okay. I didn't know so because when we were in A levels, we were never know about Tesla. This Tesla thing came up with that came up after a BBC revelation or something like that. BBC something. There was a documentary, and there was a documentary on Net Geo as well. After that, Tesla came into the picture. Right. Until that, Tesla was uh, under behind the scenes. Right. It was happened around 2006 or 2007, as I can remember. Right. You guys were after that generation, so it's very popular. It should be. Yes. So even right now as well, right? As I know, uh, the due respect is not given um, to to person who discovered uh, that SpaceX, right? Elon Musk's SpaceX, right? Actually, Elon Musk is not the person who discovered SpaceX. Find out about it. And there was a again Kotang Adinali again. Elon Musk is a person who is going in the Perahera. Perahera Yanalia. He is the world richest person, and also he can hire the people who know the things because he has money. Right? The reusable rockets were discovered not by Elon Musk. Yes, it is discovered by Elon Musk. The name is there, but he is not the real Radakaru, and he is not the real guy. They will come out to the scene after the Elon Musk surely within our lifetime. I don't know about my lifetime. Within your lifetime, they will come come out from the scenes, come out from the behind the scenes, right? So uh, the the world is like that. If you have money, you can do anything, right? Anything in the sense that not everything, but anything. You know the difference between anything and everything, right? Okay. So, all right. Now let's going to learn about characteristics of cathode rays. There is a person who called as J.J. Thomson. Thomson is like a person who has much money and he knows the person who knows the theory. He knows the person who knows the theory. Thomson is something like that. He is a very cunning guy, and he knew about these cathode rays. He knew about these cathode rays, and he started to create a group, right? Yes, on Elon Musk is working on so many things, right? I will explain that. Yes. Okay. Now listen. He built up a group, a set of people who works on the cathode rays, to work on cathode rays. Rutherford, um, Chadwick, uh, Niels Bohr. So those are actual scientists. Right? He formed a group to find out what the cathode rays or to the properties of cathode rays. Hitandoko Maliban Mudalari started Maliban something like that. Maliban Mudalari was not producing biscuits, no. He bought people who has the capability to produce biscuit, right? But still we call it as Maliban Mudalari. He is the guy who is the big guy, but the actual working people are not the Maliban guy, right? The people who are working under Maliban. This is same applicable for the other things as well. Most of the other things, right? But he know how to manage the people and how to convince others. J.J. Thomson, Newton, Thomas Alva Edison. There's some other guy as well. Like now name is not coming out in my mind. There was some other guy as well who was all over the place, right? So, uh, and I know one of my friend as well who is very who's a professor in 5G, right? He's a professor. He's a brilliant guy, but he has over 2,200 publications, but only two has been done by himself. All other 198 plus things has been done by his friends, including myself. But his name is there. Right? So uh, he's a brilliant guy. He can convince others, and he know how to sell them, how to market them. J.J. Thompson is also something like that, something like that fellow. Right? So J.J. Thomson started to find the properties of cathode rays. Write the topic, properties of cathode rays. Write the topic, properties of cathode rays. අනිකට නිදියම නෑනේ අහගෙන ඉන්නවනේ. You guys are listening, right? I'm assuming, huh? You can even dancing while learning. Okay, all right. I'm just joking. Okay. You are now adults now. You should know how to behave yourselves. Right? So now you guys are 18 years old? No, right? It's still 17 years old, right? 2004, no? 17 years old. Okay. So now you are young and you know how to deal with yourself, right? You should know how to control yourself. You should know your limitations. You should develop your own values. Okay. Properties of cathode rays. First bullet point, first one. After the invention of cathode rays, after the invention of cathode rays, after the invention of cathode rays, it was found that it was found that these rays could be deflected by these rays could be deflected by these rays could be deflected by a magnetic field and a magnetic field and an electric field and an electric field. Next bullet point. Properties of cathode rays. Properties of cathode rays. Properties of cathode rays were mainly experimented by J.J. Thomson. J.J. Thomson. J.J. Thomson. Right. Now listen, na? Dragin, na? First one that don't write up. The first property, right, in cathode ray tubes, cathode rays, not cathode ray tubes, cathode rays is they move in or move along straight lines. They move in straight lines, not in angular lines, not in like wave forms like this. It's straight line. It creates a straight line when they move. That is the first property of cathode rays. And you should know how to prove them as well. The experiment that has been used to prove it. Right? This is how you prove it. You should use, obviously you should use a crude steel like this, and you should place two plates, and you should place high voltage, and you put high voltage, and I will place this as a cathode, and this is as anode, and this will become the cathode. Remember, negative charge one, negative side will become cathode, positive side will become anode. How we prove it is, when we place an sharp opaque object like a cross like this in the path of cathode rays. A sharp object, opaque one, not transparent one, opaque one. If you place something like this, when we allow to produce cathode rays, we can see a sharp, very clear shadow in the anode side. Very sharp anode, sharp shadow like this. So these are the cathode rays like this, and it shows a very sharp shadow. Right? I couldn't mention the suction pump here. There should be a suction pump as well. Otherwise, this Crookes tube is not complete. So the first property is the cathode rays are move along in straight lines. How you observe it or how you prove it is, inside the cathode ray tube, you place opaque object, sharp edge object. We call this as opaque object. This is sharp shadow. This sharp shadow cannot be observed if if the cathode rays are not moving along the straight lines. If these are moving along in a waveform or in kind of deviated paths or not in straight line, sharp shadow cannot be observed. Only if the cathode rays are moving in straight lines, sharp shadow can be observed. So we put an opaque object and we allow to go cathode rays through this opaque object, and we observe a sharp edged shadow in the anode side. I am not saying that this is exactly producing in front of anode. It may be in the glass of the wall, or sorry, wall of the glass, or somewhere in between anode or glass. It is producing somewhere between it, or in the anode side, right? Place the opaque object middle of the crux tube and observe. There will be sharp-edged shadow of that opaque object. Conclusion is cathode rays are moving along straight lines. That is the conclusion. Any questions? These are very important things. Can be asked in A levels. Can be definitely will ask in your term tests. Okay, good question. What happened when the anode and cathode were changed in the power supply? Then the cathode and anode will change, right? Anode will become cathode and cathode will become anode. Then the cathode rays will start to emit from always from the cathode. Even though it is emitted from the other one, let's say, let's say like this, right? This is power supply, this is the cathode, and this is the anode, right? This is cathode, this is anode. In this scenario, cathode rays are moving from here to here. If we change it, if we change the power supply, if this is negative, if this is positive, cathode rays will move from here to here. Always it is emitting from the cathode. Even though it is emitting from this one earlier, it will stop emitting from there and it will start to emit from the other plate, because this will become the cathode. Always it is moving from the cathode. It will never emit from the anode. We will come to that part in later session, in later. But this is what happened when it changed. If object was clear, would something change? What do you mean by clear, Buddha? Shanak. The question was, if object was clear, would something change? What do you mean by clear? Yeah, just unmute yourself and tell me. Yeah, it's okay.
If it was like glass or colorless,
Ah, then the thing is that sharp object cannot be observed, right? If it is glass, it will emit a color. We discuss about it, right? So there won't be any shadow or something like that. So experiment will be a mess. Okay. So if it is something like, let's say, plastic or something, then there will be some other things, right? So just put something opaque, right? Something opaque which is not transparent. So and you can see a sharp shadow, right? I would prefer to place some very thick one here, very thick. Even cardboard is also enough, right? Very thick one. Okay. Uh, Only questions from Dalton's theory won't come to the A levels. Yes. Dalton's atomic theory, not in A levels. 100% confirmed. Not in A levels. Dalton atomic. But cathode rays, there are. There will be, there should be. Not maybe, there will be. Right? What is the reason for emitting rays only from the cathode? Because it is emitting from the cathode. I will explain it. Why it is from the cathode. I will come to that part. Right? I will explain it. Why it is emitting only from the cathode. Right? Because there's a reason. I'll come to that part. Okay. Just now I'm moving. I'm building this story step by step. Right. First one. Any unclear points up to now? I like I like this type of questions. You guys are thinking. That's good. That's very good. So, and also you are curious, right? That's what I need. Any unclear points up to now? Okay. Eleni, I didn't hear you today. Any unclear points? Okay, good. All right. Chirat?
Oh, sir, understand.
Okay, good. Only is it only is zinc sulfide or I'm not clear, but I think it is only zinc sulfide green color. Is it the question, Nipuni? Okay. Green color that when cathode rays are hit by zinc sulfide, it is emit green color. There are some other elements as well that emit green color. Not only like any sulfide one, like ferrous sulfide, copper sulfide, anything which has a metal sulfide will emit in green color when it is hit by cathode rays. They will they are not in your scope, but better remember, right? Can rays be reflected? Yes, of course. I will come to that part. I will. Right. Let's write down this one. Right? Okay. That's good. Okay. Um, we wrote the topic, right? Right. Continue. We wrote the topic, right? Properties of cathode rays. And yeah. Number one. Number one. Cathode rays. Okay. Cathode rays move along straight lines. Number one. Cathode rays move along straight lines. Draw this one. Today we have to draw a lot of diagrams. Huh? Here, don't misunderstand that this shadow is appearing in front of anode. It can be anywhere. Sometimes it may be on top of the anode or beyond the uh, beyond the anode on the glass. So don't misunderstand that, right? I'm just referring this, just giving you some kind of rough uh, diagram. Draw this one. Okay, if you have written down, if you have drawn, now let's write down like this. First bullet point under this, under first one. If an opaque object is placed, if an opaque object is placed if an opaque object is placed on the path of the cathode rays, on the path of the cathode rays, a sharp a sharp shadow of the object is observed. A sharp image or sharp shadow of the object is observed. Next bullet point. This proved this proved that the cathode rays move in straight lines. That the cathode rays move in straight lines. Second one, second property. Right? Listen carefully. Actually, this property has been discovered. Don't write down. This property has been discovered by J.J. Thomson. This guy with this team observed that whatever the uh, gas used inside the cathode ray tube, right? Or the cathode material used, irrespective of the cathode material or irrespective of the gas used, the properties or the nature of these rays are not different. They are identical. Whatever the cathode material or whatever the gas we use inside the cathode ray tube, the properties of the cathode rays not change. There will be no dependency from the cathode material and as well as the gas, right? And also, since these are moving towards the anode, he suspect that this is having a negatively charged particles, right? So two things he observed, two things he discovered. One is that whatever the cathode material or whatever the gas we use inside the cathode ray tube, the properties of cathode ray particles or cathode rays does not change. It keeps as identical, not changing. The other one is he suspect. Remember the word, huh? He suspect that these are negatively charged because it is going towards the anode, right? So later, not by these are what I am going to write down here is uh, not discovered by Thomson, but this has been done later. It's something like this. Let's do the cathode ray tube. Let's say uh, we have hydrogen inside the cathode. It's inside the cathode ray tube. Okay. Because of high voltage and low pressure, this will become hydrogen atoms because of high voltage and low pressure. They are broken into two atoms. And also, this is due to high voltage and low pressure. These two are very, very important, na? Low pressure and high voltage. And due to ignition, this ignition is happening. I told you that there is some kind of glow in cathode before generating the cathode rays. Can you remember? And remember, there is a glow around the cathode area. So that is kind of an ignition. You know what is ignition, right? That is happening because of low pressure and high voltage. Because of that, these hydrogen molecules or hydrogen atoms will become H plus and it will release an electrons. It has the ability to throw away the electron inside the hydrogen atom. These electrons are attracted by the anode and they are moving towards the anode as cathode rays. Now what is cathode rays? They are made of what? Electrons. Electrons. Okay. If we have helium with high voltage, low pressure and ignition, they are producing helium 2 plus ions and releasing 2 electrons. These electrons are going towards the anode as cathode rays. Right? If you have oxygen, if you have oxygen due to high voltage, low pressure, they will convert it to two oxygen atoms, and due to ignition, they will convert it to O2 plus O plus or whatever. Let's say it is O plus. These are going towards the anode as cathode rays. So what are cathode rays then? What are cathode rays then? Electrons. Electrons. Clear? So this is why, irrespective of the cathode material or irrespective of the gas that we use inside the cathode rays, the properties of the cathode rays are not changing. Because it's always electrons producing, electrons. This is not known at that time. These are found out after some time after these experiments. But now we know these are cathode rays means electrons. That's why whatever the cathode material we are using, whatever the gas we use inside the gas tube or Crookes tube, the properties of the cathode rays will not change because this is a common thing for all the cathode material and all the gases. So that is the point where J.J. Thomson said whatever the cathode rays are made of, that is common to every element. So now we know electrons are common to every element, right? If it is a helium electron, if it is a oxygen electron, if it is a nitrogen electron, all are same. Electrons are electrons. It is not changing from time to time or element to element. That is common to every element. That is how he found it. Right. That is the property of electrons. There was no experiment as such for this one. There is an experiment because he used several different gases inside the Crookes tube and observed the properties of cathode rays. And he found out it is not changing, and whatever the material, whatever the particle made of cathode rays is common to every element. So that is electron, and it is negatively charged. He suspect that, right? That's why it is going towards the anode. Clear? Any questions? There's a question: what will happen to H plus ions? I will come to that part next session, next week. There is, you can think about it, right? What is happening to H plus ions? You can think about it. Right? I will come to that part. That's good if you can think like that. Yes. Because the high voltage, does this setup get heated? Yes, of course. Definitely. Good. This setup is heated. Yes. Um, uh, I will come to this point not in the next property, but in the fourth property. I will use this heating property as well. That's good, right? Okay. H plus, I will be explaining in next session, right? There is the role in H plus ions as well. Or H plus ions or helium plus or oxygen plus or whatever the plus ions forming inside the cathode ray tube. Right? Maybe. Has it ever exploded? Maybe. Maybe. Actually, to be honest, I haven't done this experiment. So because I never had an opportunity to work with Crookes tube. It is not in if it is a government school. I never seen Crookes tube, but I'm not too sure about an international school. Uh, but I think because of that risk, it is not given to the schools because it is a very high risk experiment, as you said, Shanak. So uh, he's asking, has it ever exploded? Maybe sometimes. Yes. It can be because we are using.
The heating of the gases is a risk.
Yes, and also high voltage. That is also risk. Because you know, then you know, when you are given a Bunsen burner as well, the things that you are doing, right? You guys are trying to light it in different ways. So because of these risk factors, I think that Crocus tubes are not given to the laboratory conditions or to the school laboratories. And also, I didn't have any chances to use it in the university days as well. Right. Okay, the second property. The nature of cathode rays, let's write down the nature of cathode rays. The nature of cathode rays the nature of cathode rays are independent from the cathode material independent from the cathode material independent from the cathode material and the gas inside the tube and the gas inside the tube. Just draw this one and draw this one and write down these equations, right? I think you are clear with this. No, it is this. Draw this apparatus and write down these three equations. You guys don't write the as HV and LP, yeah? You may thinking that this is liquid petroleum and something HVO, something like that. So just write down high voltage and low pressure. Right. Mm, I didn't write down because I didn't have any space here. This is the second one actually. Write down this equation one by one. No? Let me know if there's anything unclear on this board, right? I think I I assume that everything is clear for you guys. Okay, you guys done? You nearly done? It's copied. Okay. Okay. All right. All right. Okay. Now let's write down first bullet point. In any instance, in any instance, cathode rays are electrons. Cathode rays are electrons produced through the ionization of gases. Produced through the ionization of gases. Produced through the ionization of gases. Underline the phrase produced through the ionization of gases. That is important. Next bullet point. Therefore, properties of cathode rays, are independent from the cathode material, and gas inside the cathode ray tube. Gas inside the cathode ray tube. Third one, number 3. Okay. Listen. Um, Listen now. This is a circle, and if this is the center, if I draw a line which is going through the center of the circle, last sentence. Sharon, can you repeat the last sentence for the class, please? I can't remember. Last sentence. Just unmute and tell.
Uh, Therefore, properties of cathode rays are independent from the cathode material inside the tube.
Is that okay?
Okay, sir.
Please repeat again, Sharon. Isa, tell me it's
There-
okay.
Therefore, properties of cathode rays are independent from the cathode material inside the tube.
Okay, sir.
Okay. Isa, is it okay?
Okay, sir.
Okay, great. Now, Chirat, can you tell me there is a line which is going through the center of the circle, and what is the angle of this one?
Uh, see that I don't.
Sorry?
So I don't know that.
Adisha, can you tell me the angle here? This angle. What is the value of this angle? You guys did this in all wells, right?
Is that tangent?
Sorry?
The angle like in the I don't know.
All right. Okay. Angle creating from the circumference and this whatever the line going through the center of the circle. Vinidya,
Ninety.
okay. You are saying 90. Anuk, how much is it? 90. Okay, he told me. Okay, okay, I got it. Right. Nipuni, what's the angle here?
90.
Yeah, this is 90. Anything which is going through, which is connecting the circumference of the circle. Okay, Chira, I got you. I couldn't remember. Sorry, I got you. Okay. Um, any line is going through the circle, going through the center of the circle, and connecting the circumference, right? It should be 90 degrees. It should be 90, right? That means this is perpendicular to the surface or the circumference. This line is perpendicular. Now, what I am going to do is I will erase this and make a semicircle like this. Still, if I draw any, this is the circumference. If I draw any line which is connecting the circumference and the center of the circle like this, these should be perpendicular to the surface or the circumference, and they are going through the center of the circle, or they are converging to one point. Are we clear with this mathematical point? Yes or no? Senitu, are you okay? Yes.
Yes.
Okay. Yes. Clear. Eleni, Adisha, Yenuli, clear? Shanaka, are we clear with this? Something. Okay. If something is moving perpendicular to the surface or the circumference, perpendicular to the circumference, it should go through the center of the circle. In other words, any line which is moving from creating 90 degrees angle or perpendicular to the circumference of the circle, it should go through one point. That means it all are converging towards one point. Right? Now what I'm going to do is I will keep a note on this one, and I'm going to do something interesting here. I'm going to use a concaved cathode here. This is like a semicircle. Okay. Anode is not change. Anode is not changing, and we are applying high voltage. and low pressure. Sorry, suction pump. This is anode. This is then become positive. This is negative, and this is concave cathode. So if cathode rays are moving perpendicular or emitting perpendicular to the surface of the cathode, as we learned, they should move across one line or they should converge towards one line. Lirisha, clear? According to the theory that we learned earlier from the mathematics, which is coming from the mathematics, if it is a semicircle, if we draw all the lines from the circumference of uh, circumference and going towards the center of the circle, and all these are should be going away, creating a 90 degrees angle perpendicular to the surface. So if we do this experiment with cathode rays, it was observed that when we use a concave cathode, they are converging towards one point. They are going across one point. It's like this. It's going across one point like this. So what is the conclusion then? Cathode rays are emitting perpendicular to the surface of the cathode. Unless they will not go through one point because of this reason. What is the experiment? We use a concave cathode. What is the observation? Cathode rays are moving through one point or converging towards one point. What is the conclusion then? Cathode rays are emitting perpendicular to the surface of the cathode. Satsara, clear? Clear. Okay. Genuinely clear? Anybody who has questions on this one? This has been asked at least 2 to 3 times in some way, in many ways. Isuru, are you clear?
Yes, sir.
Okay, right. So, what is the conclusion? What is the property of the cathode rays then? Cathode rays are moving perpendicular to the cathode. What is the observation? If we use a concave cathode, all the cathode rays are moving across one line. Nipuni, are we clear with that? Or any problems? Okay, great. So let's write down number 3, right? Number 3. Emission of cathode rays. Emission of cathode rays. Emission of cathode rays occur perpendicularly to the cathode. Occur perpendicularly to the cathode. Emission of cathode rays occur perpendicularly to the cathode. That's a good question. Can you draw this, Pata? Let's just draw this. Then, while you are drawing it, I will explain this. The question is, if the concave shape is more bent, the rays will meet more further from the cathode. Have you guys done focus of lenses, focus of a lens. Have you guys done that one? This is the same thing. So when you have more concave dot, what will happen to the focus of the lens? It will bring more closer to the focus, more closer to the lens. If the concave shape is not that much bent, the focus area, the focal or the focus will be more away from the lens. Same theory is applied here. Clear? Are you clear? Yes. So this one actually coming from the theories of light and the lenses. You guys done this one, right? In always. That means the two types. There are two types of lenses, and the light. If it is, I don't know. There are two types, right? Now I can't remember. Like this. Like this. There are two types. Something like this, right? There are two types of lenses, and now I barely remember these things, right? If light is coming here, it is going through. Can you remember?
Convex and concave.
Okay, this is convex. This is concave. So if it is convex, it is bit different, right? Uh, Actually, I can't remember on this one. I'm not going to do the false things. I can't remember. So this is concave one. The same structure that we discussed. See, this is concave part that we use. So if it is going through, it should go through the focus. This is F, right? There is something called C as well, right? As I can remember, C something. This is also F. This is also F. I'm not that much good in physics. I can't remember actually. So same theory, sir. Same theory. So more concave, the focus will be move center of the curvature. Okay. Yes. That is C. That is actually the uh, C is equal to 2F, right? As I can remember. It should be 2F. Yes. Okay. There's a question. Can we also discuss one question based on this part, like for us understand how the questions in asked? Of course, I will be discussing. I have distributed the theories, and I will be discussing the questions. Of course, yes, we will do definitely. Don't worry about the questions and all. I will give you a lot of questions, right? That part will be done. Don't worry about it. I will discuss the questions as well. Let's focus on the theories first, then we will discuss the questions. Yes. There will be some additional classes on to discuss the tubes. So I will kind of like I will build you. I will you are like something something like clay to me. So I will build chemistry on top of you. Don't worry about it. So have you drawn this one? I've drawn. Then first bullet point. When a concave cathode is used, when a concave cathode is used, almost all the cathode rays almost all the cathode rays travel across the focus of the cathode. Next bullet point. This shows cathode rays are emitted perpendicular to the surface of the cathode. Perpendicular to the surface of the cathode. Okay. Right. So don't write. So next week, I think everything is clear up to now that we have discussed today. Next week also there will be the class that is 17th of April. No? So I won't be giving any leaves because all the holidays for the class because we need to keep the momentum, right? Soon after starting the class, don't miss the class next week. It is 17, so the Urdu is almost gone after 17, right? I'll be conducting the class for the, on the same at the same time. 17th of it's 17th, right? Yes, 17th. So 17th, 7 p.m. So I'll be now. There are many cathode ray properties that we need to learn next week. I'll be finishing off the cathode ray properties next week, and I'll be starting what do you call that? Liresha asked me about what will happen to H plus ion. So that is a separate lesson. I will be starting that lesson as well. Right. So next week, don't miss the class because cathode ray properties very popular question that in the term test as well. So we can discuss it. I think everybody got the tubes. I have distributed the soft copies. So you can, if you need the hard copies, I can post it if you need. So if you need, let me know with your home address. So drop a personal message if you need, right? So next week I'll be finishing off the properties of cathode rays and I'll be starting what is happening to H plus ions. Right? So actually, I think you can, if you are celebrating singular New Year, I wish you Happy New Year, Sabal Thaurda Peva Hamatam. If you are celebrating the New Year, and wish you good luck in the upcoming New Year. If you are when we will be meeting in a New Year according to the single tradition. Single Hindus is also celebrating. Adisha, Puta, you also celebrating New Year or how about you? In Jaffna?
Yeah.
Okay, all right. So, Liresha, you also celebrating, right? If I'm not mistaken. Yes. Okay. So I don't know how to wish in Tamil. Sorry about it. So, Hamotum Subalutavda Keva. We will be meeting in a new year according to our beliefs. So, 17th April, uh, 7 p.m. Right? Okay, then. Have a nice week, guys. Thank you very much.
Thank you, sir. Bye, sir. Have a nice week. Happy New Year, sir.
Have a good night, sir.
Good night.